In this demonstration, I'll show you how to find the derivatives of trigonometric functions using the chain rule. This is part 1 of the series. In calculus, the chain rule is used whenever you have to find the derivative of a composite function. In question number 1, they're asking us to differentiate sine x minus 5x to the power of 3 all power to the 6 plus cosine x. We'll start off with this part, and we will use the power rule slash the chain rule for this. So this 6 goes to the front, and it reduces by 1. Next, we'll find the derivative of that part. The derivative of sine x, and I do have a video dedicated to finding the derivatives of trigonometric functions. The derivative of sine x is equal to cosine x. And the derivative of this term is equal to negative 15x to the power of 2. Your next step is to find the derivative of cosine x, and the derivative of that is equal to negative sine x. Now this question is relatively simple compared to the next few, because in the next question you'll notice that the term is no longer just a simple variable, but it's actually a product. So let's move on to question number 2. Here we have two functions. Let's call this f and let's call this g. We'll use the product rule, and in addition to that, the chain rule. The product rule tells us that you find the derivative of this, leave that the way it is, and then you find the derivative of this and leave that the way it is and add them up. For example, the derivative of f plus the derivative of g times f. So let's do that. Start off by finding the derivative of f. That is equal to negative 2e to the power of negative 2t. And the way I did that was I found the derivative of this using the power rule, and I placed it right here. Next, we'll keep this the way it is, sine 3t, plus, keep that the way it is, and find the derivative of this. Now the way you would do that is first find the derivative of sine, and we know that it's cosine, and keep that part the same. Next, find the derivative of this part. This is where the chain rule comes into play, and the derivative of that is equal to 3. Now oftentimes your professor will not expect you to simplify chain rule examples, and the reason why is because a lot of them end up becoming very complicated and hard to simplify. So for the sake of this tutorial, we will simplify one step and that's it. So we have negative 2e to the power of negative 2t sine 3t, and here I'll bring this 3 to the front, e to the power of negative 2t cosine 3t. Let's move on to question number 3. Here we'll use the chain rule exclusively. Sine is cosine, and we'll leave this part the same. And the next thing we'll do is find the derivative of this. And the derivative of that is equal to negative sine x squared. And then you'll find the derivative of this as well, which is equal to 2x. So to simplify, I'll bring this 2x at the front. In addition to that negative, cosine x squared sine x squared. Moving on to question number 4. Here we are asked to differentiate sine to the power of 2 cosine x. Now if you're not familiar with this notation, this is the same as saying sine cosine x to the power of 2. So we're going to use a combination of the power rule slash the chain rule. Now if we do that, we'll bring this 2 to the front and leave everything inside the way it is. And at the same time, we'll reduce this by 1. And now we will differentiate this part. The derivative of sine is cosine. That stays the same. And now we're going to find the derivative of this, which is not hard to do. We know that it equals negative sine x. So just to rearrange everything, this negative goes to the front. Negative 2 sine cosine x cosine cosine x sine x. Perfect. And finally, in the last question, we are introduced to tangent. And the way you differentiate tangent is shown right here. So let's go ahead and try to differentiate this. We'll start off by concentrating our focus here. Remember, this radical is the same as saying y is equal to x times tangent 5x minus 3x to the power of 1 over 2 and everything else. With that said, we will bring this number down, 1 over 2 x tangent 5x minus 3x negative 1 over 2, so I subtracted a 1 from here. And now we will differentiate this part. I'm just going to ignore this part of the question for now and just focus on the yellow. So let's start with this product. And we're going to use the product rule for that. So we'll start by finding the derivative of this one. And just to be very explicit, that will be my f and this will be my g. And remember, the product rule is the derivative of f times g plus the derivative of g times f. So we'll differentiate x, which is equal to 1. We'll leave this the same. Increase the amount of space here. Now we will differentiate tangent 5x, which we know is equal to, according to this, secant squared 5x. And then differentiate the 5x, gives us 5. And you leave the x the way it is. Similarly, we will also differentiate this term, which is equal to negative 3. Now let's put this all together. Now remember, I was only focusing on this. So we have 1 over 2, that. And I'm going to simplify this. And if I simplify that, it should look like this. Tan 5x plus 5x secant squared 5x minus 3 to the power of negative 1 over 2. And also, time to differentiate that. And for that, I'll do it right here. To differentiate this, you differentiate the exponent using the power rule, minus 1 e x to the power of 2 minus x. And we're going to bring this over here. Put a plus sign. And there you have it. Those are 5 solid examples on how to use the chain rule with trigonometric functions. The next video will concentrate on more examples related to trigonometric functions and the chain rule. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.